Let's begin. Today's December 13th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 3, 7, 12, 17, 19, and 21. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our middle digit, the square digit, and the Turing machine compares it to the number 3. So should the value of square be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B takes a look at our last digit, the circle digit, and the Turing machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at our first and last digits, triangle and circle, and compare them. So should the value of triangle be less than circle? Should they be equal, or should the value of triangle be greater than circle? Criteria card D will take a look at the 3-digit solution, and the Turing machine will let us know how many evens there are. Are there no evens? Is there a single even? Perhaps 2, maybe even all 3 are even. Criteria card E will take a look at the first 2 digits, triangle, square, add them together, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F again takes a look at the 3-digit solution, except this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 2 cases. One where the 3-digit solution has a pair, as in the example 131, or alternatively, there are no pairs, but there are 2 scenarios. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card B. Okay, so the Turing machine does not approve of my choice in circle. I did pick an even 4, but because the Turing machine does not agree with that, it's actually informing us that circle should actually be odd. So let's go ahead and type that up in our notes in section B. And that is that the circle digit is an odd digit. And of course, since it is odd, let's go ahead and cross out the 2 evens. Okay, so I think the next thing I'd like to test is criteria card F. Okay, so in this case, the Turing machine does approve of the proposal 314. Notice that all the digits are distinct. So it's basically informing us that the solution has no pairs. So let's go ahead and type that up in our notes in section F. And we'll state that the solution has no pairs. Okay, let's see. But again, we do have those 2 scenarios. Is it enough? Do we have enough information to be able to determine if the digits are all distinct or all the same? I think at this point we don't know. Okay, well, let's keep going and let's actually test criteria card E. Okay, so the Turing machine again approves of my proposal. For criteria card E, we are adding up the first 2 digits. So 3 plus 1 is 4, and 4 is less than 6. So it is true that if I add up the first 2 digits, the sum should be less than 6. So let's go ahead and type that up, and we'll say that triangle plus square should be less than 6. Okay, and what can we say? Well, if we want to restrict the sum of the first two digits to be less than 6, then I don't believe that either could be a 5. Because if we add up any 5 with even the smallest of a 1, that sum is already 6. And so there's no way that, if you add 5 with anything else, it's only going to get bigger. So yeah, so we know our solution can't have 5s in triangle and square. But anything else, 4, yeah, you can add it to 1. And then, there's tons of other combination of digits that'll produce a sum that's less than 6. Well, I believe that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing that middle digit to the number 3. We also didn't test criteria card C, comparing our first and last digits. And of course, we also did not query how many evens there might be. Well, now that we've established that the sum of the first two digits is less than 6, the interesting scenarios are if somehow triangle or square are forced maybe to be a 4, then that would force the other digit to be a 1. So, sort of thinking in extremes. And we do have criteria card A that would let us know what square might be. So it could be that, if square were greater than 3, meaning 4, that would force triangle to be a 1. So we'd have 1, 4, and let's see. And because of, if it's true that there are no pairs, meaning, or actually the specific case of that it's not a single digit repeated, but they're all distinct, it could come down to be 1, 4, and circle would no longer be a 1. But that would make, well, yeah, I don't know. That would kind of make circle obviously still be odd, but I wonder if that would somehow give too much information, making maybe criteria card D irrelevant. I'm not sure. Somehow the number of evens has to come into play somehow. Well, we can't have pairs. So and yeah, so I'm thinking, I don't know if we can even have, we could have at least, I guess, a single 4, but we can't have 2, 4 or 4, 2 because that sum is 6. So we know we can't have, obviously 3 is out of the question because there are no evens in circle. And so it's either no evens, a single even, and a single even. It can't even be 2 because any combination of 2 and 4 will give us 6, which would be contrary to what we discovered in criteria card E. So either there is an even or there's not. And if that even would be 2, I think there would be too many possibilities, whether it's triangle or square. There'd be too many possibilities. Well, I guess, not too many. It's either a 1 or a 3, if there is. And I guess you could have 3 odds, maybe something like 1, 3, 5. If there are no evens, it'd be somehow 3, 1, 5 or 1, 3, 5. Yeah, it could be that. 135315. And also, I guess, going back to that 1-4, and then somehow, yeah, we have to incorporate criteria card C comparing. So 1-4, but at that point, triangle would be smaller than all of those, which would be ambiguous. So I don't think it would be 1-4. It could be that maybe square is less than 3, and there may not be any odds. So it could be something like maybe 3-1-5, perhaps, or 1-3-5. No, it wouldn't be 1-3-5 because we'd have the same problem, I guess. Actually, yeah. Let's do, well, yeah, somehow. How would we use criteria card C? 3-1-5. Maybe there is an even. It could be smaller. So 3-2. Maybe this will be it. It might be 3-2, and then criteria card C would be picking the odd that's either 1 or 5. Yeah, I kind of like that. So let's go ahead. I'm going to pick 3-2-5. Let's see, if we pick square to be less than, how would we know that's even? There's only one even. Square is less than. Yeah. Oh, wow. Let's just go with 3-2-5, and hopefully, if we're wrong, we can still learn from the mistakes. Okay, but just in case, is our last digit odd? It is. The sum of the first two less than 6. Yeah, 3 and 2 add up to be 5, and there are no pairs. Okay, well, let's give that a try. Okay, so I guess, let's see. Let's go ahead and test criteria card A first. Okay, so it is not the case that square should be less than 3. Notice that my choice of 2 is less than 3, but that is not correct. So let's go ahead and say that either square is 3 or greater than 3. So let's go ahead and type that up in A. And again, we're going to say that square is either equal to or greater than 3. And since, again, my proposal failed, we can actually cross out the 1 and 2 from square. So we know it can't be 1 or 2. Now we don't know if it's 3 or 4, but let's see. If I think we can cross out, because now square is either 3 or 4. I think we can cross out 3 and 4 in triangle, because if you add 3 and 3, that's 6. And of course, 3 and 4 is 7. That's too big, and triangle 4 is even bigger. So yeah, I think we can cross out the 3 and the 4 in triangle. And so let's reassess here. Yeah, 3 can add up to both of those, but 4 can only add up to 1, which is one of the ideas I had earlier, but chose not to go down that route. Okay, so what else? Does that affect anything else? No, I think it's okay. Let's go ahead and, well, it will be interesting now what criteria card C might reveal. Obviously, if there are no pairs, I have a hard time believing one would work, because one would be greater than 3 and 5. And so I almost feel that may be that there's a 2. So that would be 2, 3, and then yeah, we'd have to figure out, is triangle smaller than 5, or should it be bigger than the 1? That would be my guess. But let's go ahead and test criteria card C. Okay, so let's see. Triangle should be smaller than circle based on my proposal, since the Turing Machine agrees with it. 3 is less than 5, so yeah, triangle should be less than circle. So let's go ahead and type that up, and that's in section C. And we'll say triangle should be less than circle. Okay, so let's see. So that it looks like then circle can't be a 1, because if circle were 1, there's nothing smaller for triangle to be. So I think we can cross out the 1 in circle. And yeah, at this point, both 3 and 5 are bigger than the 1 and the 2. So at this point, yeah, I can see either having no evens, right? It could be something like 1, 3, 5, or it could be, a single even. Well, let's go ahead and test criteria card D and see. Okay, so it agrees that there should be a single even. Since I only have an even in my proposal, the Turing Machine approves of that. So let's go ahead and type in our notes that the solution has a single even. Okay, well, since it has a single even, let's go ahead. Maybe we should write out the possible solutions. So let's see, what would that look like? We should have enough information, I would think. So we need an even, so let's pretend it's the 2. So that would be 2, 3, 5. And that's the only possibility, because 2 plus 4, well, that's 6, and also has 2 evens. So if triangle is not the even, then triangle is 1, and 4 is the only available even. And then at this point, is it 3 or 5? Now those may be ambiguous solutions. So 1, 4, 5. Okay. Well, let's see. Yeah, they all have. Oh, we did not test criteria card A. That would be, yeah. And actually, that probably would have been a better test than the number of evens. Well, maybe not. But that, yeah, well, maybe. Yeah, that may have been a better test to try. Okay, well, let's see. So the last two have square be larger than 3. Okay, so that's what they share. We don't know that for a fact, but let's presume that that's true. They both have an odd circle digit. In both cases, triangle, the first digit is smaller than the last. One is less than 3 and 5. That's true. Both only have an even. their sum is less than 6, and there are no pairs. So I would say that these last two are ambiguous. I can't tell them apart based on the criteria cards. So it looks like 235 is the only possible answer. And so let me just confirm, yeah, 2, 3, and because of the no duplicates, yeah, 2, I guess technically is smaller than 5. So yeah, I'm going to go with 235. And so let me type that up here. And let me add some notes here where I'm going to actually cross out the, let's see, I'm going to cross out the greater than, because it seems like square is 3, and I'm going to say I'm deducing that. So let me cross this out. And I'm just going to write an additional note here that I'm going to deduce that. And let me get some space here. Okay, so I think that should be our answer. Let me go ahead and cross out the 1 in triangle and the 4 in square. Now the only thing that concerns me is this 3 being crossed out because of the duplicate rule or what? Maybe. Well, let's go verify. 235. Two, 3, 5. Okay, yes, fantastic. Well, how did we do versus a Turing machine? Well, this is a 6 criteria card puzzle, and we did exactly 6 tests. And in the first round, we did B, and then E and F were correct. And in the second round, we did the 3 remaining. We didn't have to test twice on any criteria card. And then we did A, C, D in the second, and C and D are both correct. So let's go ahead and type B, E, F in the first round. And again, B was incorrect. E and F were correct. Second round, A was incorrect, and both C and D were correct. And how do we do? Wow, I am surprised that we beat the Turing machine by 2 questions. Well, I will say, technically, we like I stated, we didn't have to test anything twice. So I think we were quite fortunate, especially in some of, say, like criteria card A, C, and E, which all have 3 possibilities. We were able to deduce criteria card A, and we were fortunate to get C correct as well as E. So whenever you guess accurately, or maybe just get a little bit of luck, these possibilities, that there are 3 of them, can get tricky where you have to test them multiple times. We didn't have to do that this time around. So yes, definitely feel rather fortunate there. Well, how about you? How did you solve it? Did you pick any criteria cards that led to some sort of aha moment, some kind of discovery that's kind of unique to the puzzle? Please add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.